All right, we're going to be taking a look in this lesson at surface area of a sphere and a hemisphere. Now, really what it comes down to is we are taking a look at what is the surface area of a ball. Okay, a ball. That's our sphere. That is what we would recognize as being a sphere. So, a little bit introduction here. A sphere, often more commonly known as a ball, is any perfectly round object which has the same radius throughout the whole object. Okay? So again, for the sake of this class, all objects we think of will be thought of as round, and this ball here is my example of a sphere. A sphere, again, this one may not be perfectly round like we would consider all of what we have, but it is a nice sphere. Okay, it's circular. Okay, our circumference, our radius, our diameter, they're all the same throughout the entire ball. Okay, and that's what we're going to understand as a sphere or a perfectly round object that we are taking a look at throughout the course of this lesson here or this class in general. Now, when we talk about surface area, we're trying to figure out what is the area that covers it. Okay, what is that area all the way around that covers it? And if we were in class, and I may do this in class, I'll show you kind of a demonstration of how we might think of it. But here's a couple images that come to my mind when I think of the surface area of a sphere. We have the globe, our Earth. Okay, trying to visualize it as best as possible. We often splatter it up in a big rectangular shape, but we have to distort our surface area because it's a round thing can't go into a rectangular thing. This here is one of the better representations of what the world actually looks like on as a flat. Okay, here's another way we could think of it as a whole bunch of like little, I'm not even sure what those things are called, but a bunch of little sticks that have kind of a rounded shape and a point on top. When we curl them all together, we would come up with our ball. It's super hard to draw a net of a sphere. It's even more difficult to come up with a formula to find the surface area of using any of the shapes that we already know. What we're going to do is we're going to visualize it as a rectangle. Now, again, this isn't necessarily the best way to recognize it, but it does work to come up with our equation or formula that we're going to use, and we will use this equation as we go. So the area of a sphere is going to be equal to the area of a rectangle, which has a height, right, that is the same as the diameter, and a length, which is the same as the circumference. So what we're going to do is, and this is the way that we do it here in math, it really does work, and it is in a way of finding our area, is we're going to take this rectangular piece of paper, so to speak, and wrap it around and then fold it up. And when we fold it up, it would end up covering the entire thing if we cut pieces and put it all together on our sphere. So we're gonna use this rectangle as being the same area as our sphere. Now, the length or so the height of the rectangle is going to be the same as our diameter. Okay, so we can do d there for diameter, and our circumference is the length, and so circumference we write as pi times diameter. So that would be a representation of the length of one side of the rectangle and the height of the rectangle. If we know the length and width, or the height and base, or length and height, or whatever of our rectangle, we can find the area using one of our formulas. Now there's a second way to label this, and I'm going to do this in a different color here, the blue. Our diameter could also be thought of as 2 times the radius, 2r. Okay, it's 2 times the radius. So that's the same as our diameter. Okay, it's the height of our sphere, and our circumference could also be written in terms of r. It would be 2 pi r. 2 pi r. So we can think of these as both being dimensions of our rectangle here. Now let's use those dimensions to solve for a formula for our sphere. Now, the first thing that we should probably recognize is that we could have a couple of different measurements or of our sphere. The first one to remember here is that we could have our diameter. And let's just type that in there. We could have D, which is our diameter. And I'm going to do that in pink, and hopefully we can recognize that being in pink. And then I'm also going to do the other one we could have, and I'll do this one in green, is our radius. Okay, it is the halfway across. You know what, let's actually do it down here. Okay, it's halfway, so that would be our radius. Goes from the center to the outside. There we go. So we could have diameter or radius. Okay, either or, and we can actually solve for our circumference using either one. Or sorry, not circumference, our surface area using either one. All right, first method, and this is using diameter. What we're going to do is we're going to do the diameter times pi diameter. Okay, diameter being the height and pi diameter being the length. And so we do diameter times pi diameter, and we can actually simplify this because we have two d's being multiplied together. And so our surface area is going to be pi diameter squared. Done. There's our surface area of our sphere. Pi times diameter squared. That's if you have the diameter. If you have the radius, you may want to use radius calculations. Now, I will be honest, this is a little bit bigger here. We do 2r times 2 pi r. Again, that is our height and our length, and we multiply the two of them together. We can collect kind of our like terms or multiply together our like terms. 2 times 2 is 4 pi, and r times r is r squared. So 4 pi r squared and pi times diameter squared both give us the surface area of our sphere. Both of them give us the surface area. You can use either one. If you're given the diameter, use the diameter one. If you're given the radius, use the radius one. They're both going to give us the exact same measurements. Now I'm going to do a couple of examples with you here. Okay, so the first one here is a sphere that has a radius of 4 millimeters. Now you notice that it's a radius because the line only goes halfway across. It goes right to the center. Diameter, it goes all the way across. So we're going to find the surface area of this sphere right here. And because I have the radius calculation, I'm going to use the radius equation. Okay, so I'm going to plug in, so there's my radius equation. I'm going to plug in my radius, which is 4 millimeters, and we're going to square that. We're going to type that into our calculators. So this is 4 times pi times 4 squared. Now I'll put that up there so you can see kind of the way I've typed it in. 4 times pi times 4 squared. Okay, and we get an answer of, let's just quickly get this going here. Surface area is equal to 201.06 millimeters squared. And so there's our answer. That is the surface area of our sphere. Now you're saying, well, what if I liked the other formula and I want to use that one instead? Well, let's use that other one with the same measurements. Let's see if we get the same thing. Surface area equals pi times diameter squared. Well, now we need to know the diameter of our sphere, and that's just double our radius, right? So we double the radius, that's going to give us our diameter. So pi times 8 millimeters squared. And when we find the surface area, now I'm going to type it in again. I'll show you with my calculator. Times 8 squared. Okay. Ooh, there we go. Let's get it on there. Pi times 8 squared. And I get the exact same number, which I should. Okay, 201.06 millimeters squared. Okay, we get exactly the same number, which we should because we're finding the same surface area. We're just using a different measurement. We're using the radius or the diameter instead. All right, let's use the same thing. Here now we have a diameter of 7 centimeters. Okay, so we're going across. So that is 7 centimeters. Let's find the surface area of this question here. Now, again, you can use either formula. Because I'm given the diameter, I'm going to use the diameter formula. And so it's pi times 7 centimeters this time. And when we solve it, type that into the calculator here. Pi times 7 squared. And I get 153.94 centimeters squared. There we go. 153.94 centimeters squared. Again, important thing is when we're doing area, we always put our units squared. Okay, it represents an area measurement, not a length measurement. Okay, so it's important that we put in squared. You don't need to write in your units when you're doing the calculations. I want to see your calculations, how you're writing it out, but you don't have to write in your units. I will almost always do that. But for your answer, you need to make sure you're showing your units.